Hello everyone and greetings to my presentation from RCE to Shell when the stars are not aligned. My name is Zoltan Balazs and I'm the head of Vulnerability Research Lab at Kujo AI. I'm the developer of the Zombie Browser Toolkit, the Hardware Firewall Bypass tool, Malware Analysis Sandbox Tester tool. I did play with some crappy IoT devices and my RCE ended up running on 600,000 IP cameras. I also invented the idea of encrypted exploit delivery via the Diffie-Hellman key exchange. I'm the co-organizer of the Hacker Shuli meetup and program committee member of the Hacktivity conference and volunteer at IoT Village. So it happened like almost 7 years ago that I bought this very nice cheap Chinese IP camera, and turned out that it was easier to hack the device than to set it up. If you look at the very nice web interface, you can see how much money was spent on the user interface and on the security of this camera. When you unbox the device, you can see the username and the default 4-digit password on the bottom of the device itself. And I also checked the documentation, whether I can find any surprising parts there. And one of the fun parts was this warning that in most cases, this concerns an electronic device and wrong or improper use may lead to severe injuries. And yes, I can confirm that if you try to throw this camera to the wall very hard, it can cause severe injuries. Now, this is how a very basic interaction with the camera looks like. So if you already authenticate to the camera web server, this is how the whole authentication goes. Instead of using session cookies, it uses the very old digest authentication. And even though it is not that bad from a security point of view, whenever someone sees digest authentication, they can be sure that this device was developed ages ago and probably was not updated ever since. So I did a quick Nmap scan of this IP camera, found the telnet D on the usual telnet port. First, I didn't spend too much time on this. I just manually tried 3 passwords and got bored with it and tried the more interesting web port. And first we will go into the details of this HTTP web server. There's also a port, which I have no idea what's going on there. If you have any documentation on this port, just let me know. Just a quick comment about the Open Telnet port. You might not know this, but the Telnet protocol was first invented in 1969. What can I say? This is not a very recent protocol from a security point of view. Fortunately, this telnet port is usually not open to the internet in a usual home network where all the devices are netted. But as later turned out, this password, which protected the root account on the IP camera, is already in the Mirai list. So if anyone happens to put this camera on the internet, it can get infected very, very quickly. Now let's discuss the exploit. I found this exploit by accident because when I was setting up my camera, I did let my password safe to generate random complex password. And funnily enough, it generated a $sign into the FTP password part. And when I was setting it up, the whole FTP part was not working, and I had to manually debug what's going on, why it is not connecting to my web server. yeah, after running some Bioshock and other debugs, I quickly realized that yes, this is probably because the server was interpreting the password as a separate Linux command, and that's why I have started to investigate this command injection vulnerability. What's interesting from a security point of view regarding this web server, that it is usually open to the internet due to the UPnP protocol. But we will discuss this a little bit later if you don't know what UPnP is. So for example, if you configure your FTP settings in a way that you put a command into the FTP user or password field, it will get executed. So, okay, we have a command injection, but how do we go from here? It's important to note that at this stage, this was an authenticated command injection vulnerability. So, funnily enough, the FTP part is not the only configuration part where you can do some remote command injection. The same vulnerability could be found on the SMTP config settings as well. So back then, I notified the vendor of this device, and I got a feedback that they will look into this issue. And 1 year later, I contacted them again. Let's see how it goes. Unfortunately, this did not end pretty well. And the current status of this patch of the camera is something like this. If you visit the website of this vendor, at least you can find the website of the vendor, but there are no patches or firmware updates for this device at all, and 7 years passed already. So I created a blog post about this camera, and turned out it got picked up by the internet pretty quickly. This is still the #1 blog post read on my blog by far. As you can see here, this spike is where I have published this blog post. And even though there's nothing fancy in this, still it looks like people are interested in cameras and hacking. Now let's discuss the different ways I tried to exploit the device, but how I failed. The first confirmed command injection which worked was using the ping command, and this was really interesting because I was able to leak, for example, to print the current working directory. What's a bad idea is to use the reboot command in a command injection scenario, because as it turned out, this is a persistent command injection, and after the device reboots, this command injection will be executed again, which meant that my device ended up in a persistent reboot cycle. And yeah, it was not very fun to recover from this stage because the factory reset button did not work on the device at all. So I also tried with different stuff like leaking out the password file by using different tricks, but at the end it turned out that there are many commands missing from the camera BusyBox installation. So, and because this whole command injection is practically running in the background in a totally blind scenario, it's very hard to debug what's not working in your exploit code. So for example, when I tried this exploit, turned out that yeah, there is even no tr command on this BusyBox implementation. So this is why it failed. I also tried some open source tools to test this command injection vulnerability, but yeah, at that time it tried to do something and it looked like it found something, but at the end it just did not work. So automated tools are not always the best option to find these type of vulnerabilities. So the best way to go forward with this exploit was for me to practically use the change password command on this BusyBox implementation, and I changed the password for the root user to a value I already know, which I provided in this exploit. And lo and behold, after providing this command injection and this command was executed, I was able to log in through the already running telnet port with root privileges. Meanwhile, others also experimented with these type of cameras, and they found some other and maybe better ways to exploit this. For example, by starting a new session of the telnet daemon on a newly specific port, and if you start the telnet daemon with these parameters, it will start in a passwordless way and will give you command shell instantly without providing any passwords. Already had this vulnerability and I was able to log in. I quickly started to investigate the root cause of this vulnerability, and turned out that practically what happens in the background, that through the web interface a new batch file has been created by very simply and plainly concatenating the username and the password in this bash script. And as you can see here, practically what happens is that the FTP command is executed with this FTP script, but anything which was put here will be interpreted by the shell as a new command, and this is what gets executed. After fiddling with the device itself, it quickly turned out that I was practically using the hardest way to log in to this IP camera, because if you Google the password hash of the root user, you can see that it corresponds to the password 123456, which is probably not that secure. And you might ask whether this whole open telnet port is documented in the user guide. Clearly, it is not documented. So regular users, they just don't have a chance to know that there's an open telnet port running on this device with root privileges. As I already mentioned, this command injection vulnerability I found it's only available after post authentication. So if there is no authentication bypass in the device, then probably it's safe, right? But the bad news is that there are multiple pre-authentication vulnerabilities on this device. I think the first bypass, this is the funniest of all, because the BusyBox web server had this known vulnerability that if you provide wrong leading characters for the URL path, then it will bypass the authentication. What you can do here is, for example, to forget the forward slash before the logging in CGI, use a backslash or use some encoding, and this way one part of the web server will understand these URLs as valid URLs, but at the same time it will bypass the authentication part. What's even worse is this one-liner that the system.ini file is practically the clear text configuration file for the device. And even though it should be protected by authentication, But again, this part of the authentication was poorly implemented, meaning that if you provided the username and password parameters in the HTTP GET request, but did not assign any values to those, you can download the clear text config file for the IP camera. Okay, but what's inside this clear text config file, you might guess? Well, for starters, the web admin password is clear text in this config file. And also, whenever people use the Wi-Fi password will be there. All the FTP configuration settings, SMTP configuration settings with all the passwords are here. And this is pretty bad because the HTTP web server port is usually open to the internet, and without any authentication, one can practically find out the valid username and password pretty quickly. There's also a very easy to find buffer overflow on the device. If you search for this exploit, then you can find a very long and detailed post on how you can exploit this. Exploiting it is not that straightforward, but as you can see, even the most trivial attempts of fuzzing, you can find pre-authentication code execution vulnerabilities in the device. I have also read that other researchers found very easy to exploit path traversal vulnerability on the device. For reasons unknown to me, this did not work on my device, but yeah, I'm pretty sure that this worked on those tested by these people. What's really funny about the first bypass, if you remember, where the leading character of the URL was malformed, that this was a known bug since 2004. So I bought this camera in 2015, which means that these people were using a firmware for this device which did not receive any patches for more than 10 years. And as I mentioned, I still have not received any patches for this device ever since. So this is one of the main issues with IoT, that when you buy it, it already has a lot of vulnerabilities, but sometimes there's no chance that it gets updated after you buy it. Now, what's interesting with the telnet port is that the default telnet port 23, or if you are spawning a new telnet daemon on port 4444, in a default network configuration, like in a home network, it will not be available from the internet itself. But luckily, for us, the firmware already contains UPnP binary. And what's really nice regarding this binary, that through the telnet or through the command injection, you can practically tell the router itself that, hey, I want to open this device and this port to the internet, so it gets accessible. Clearly, if you don't have already the telnet access, then you won't be able to use it through the telnet, but I can assure you that you can run this binary through the command injection through the web interface. And once you can configure this telnet port to be opened to the internet, then you have practically almost everything you need to access this camera device. Here you can see the results of running this command. Okay, now that I have telnet access, there comes the question, now what? How can I upgrade this telnet connection to something better? For example, what if I want to analyze stuff on the device? how do I download these tools? Quickly turned out that I was quite restricted in this environment. Like there was no wget, no curl, no netcat, no TFTP. So I was scratching my head, okay, what do I do now? And honestly, after I found a very nice way and generic way to drop binaries on a restricted environment like this, then I found out that, oh, I totally forgot that it has FTP. So anyway, I still find that the solution I will show you very soon is a good and viable solution, even in cases when you don't have the FTP. You might also ask, why do I need a proper shell if I already have telnet access? First of all, I wanted to dump the firmware, and just by having the telnet interface, it's not possible to do that. And unfortunately, I did not even have the SD card version of this camera, so it was not possible to just dump and copy the firmware to the SD card and remove the SD card itself. So first of all, I knew that I had to use some kind of binaries in order to have a proper shell. But in order to do that, first I had to figure out the correct architecture and endianness for the camera. Unfortunately, there's no file command on the device itself, so I was out of luck for that. And if you query the /prot/cpu info node, then unfortunately it won't tell you the endianness. It can provide you that, yes, this is a MIPS CPU, but nothing else. And I also tried to look for commands which might work, but these commands were missing again from the firmware. So this limited environment had really constrained me in going forward. Clearly, as there are only two different options for the MIPS and the NS, like big or little-endian, I could have brute forced it, but I wanted to do this in a proper way. And if you look at the ELF binary and how it's constructed, if we look at the very beginning of the ELF, you can see that there is this EI class, EI data section, which explains that, hey, this is a 32-bit little-endian ELF binary. All right, so what I have to do right now is just to have a hex dump or similar from an ELF file, and then I know already that whether this is a little or big endian device. Unfortunately, hex dump was not available on the device, but luckily the cat command has the -a parameter, which means show all characters, and this was the solution for my problem. So for example, if you check the little-endian binary with cat -e, then you will see a characters here, but if you run it on a big endian, then you will see a B character here. This is for the 32-bit versions. So yeah, finally I was able to figure out the endianness of this device by using the cat command. Now, as I mentioned, there was no tool, or at least I did not find a proper tool to download binaries to the device. What can I do? Clearly, copy-pasting commands is a good way to go forward. But unfortunately, if you just start with any statically compiled ELF files, for example, you compile netcat or whatever, even a very simple hello world statically compiled is 600 kilobytes. So this is not the good way forward, because yeah, converting this to something useful and copy pasting it into a telnet session, well, I tried that, and it took me almost 1000 seconds to copy paste this ELF file, which after conversion was 3.4 megabytes, and it didn't even work on the first run. And this was on a local network, actually. So yeah, good luck with that. Luckily, we have Metasploit and MSF Venom, which was really nice because it was able to generate small ELF binary, which works even though it's not a statically compiled binary. Now my next step was to convert this binary into a format which I can copy paste into a telnet session. And this was the one-liner I have used on my host machine in order to convert the ELF binary into a bunch of echo commands. So let's try and dissect what this one-liner does. So the XXD with the -p parameter converts the binary to multiple lines of hex strings. Fun fact, do not use the hexdump utility because it can mess up your endianness, unfortunately. Now the next part, the sed-e, means that we will use the stream editor in extended regular expression mode. Now this part means that we are checking for a group of 2 characters, and we replace these with a leading \\x, followed by the selected 2 characters. This is practically used for defining the hexa characters, which will be later be interpreted by the echo command. And if you know regular expressions, that you know that this part is where we store the results of the search of the first variable, and later then here this is where we are back referencing to this as \1. And finally, the G part means that we want to do this replacement for every occurrence. Now, the next part means that we will add leading echo -na command to the beginning of each line. And finally, this part means that we will add the closing quote, and we will redirect the output of the echo command into file name. I was actually expecting that I don't have to use this very odd looking one-liner, and MSF Venom can do this for me out of the box. Unfortunately, I could not figure this out, how you can do this, that you generate an ELF file and then use it in a shell format like this. Like you have this sh format which stores the shell code, for example, in a variable, but it's not an ELF format, so it's not totally useful for you. So if you have any good solutions without using this command and with Metasploit, just let me know. Now this is what I ended up with, that with MSF Phenom you can generate your reverse TCP little-endian MIPS ELF binary, which connects back to my Metasploit server, where I am running this Metasploit handler. And lo and behold, I was able to get a proper shell. But actually I have a full video about how you can do this whole hack from the beginning till the end. I was running this hack on the local network, so I did not add the UPnP trick to that, but you can imagine that it's just one extra step. So here you can see that I generate the F binary for the reverse TCP MIPS little-endian interpreter binary. And once it's generated, I start the Metapreter handler in Metasploit. All right, the handler has been created. It's listening on port 1, 2, 3, 4. And this is the part where I'm using one of the authentication bypass. And here you can see that I'm sending an HTTP GET request to get the clear text config file with the username and password parameter set to empty. And lo and behold, here you can see this is the username, and this was the random password I did set up for this camera. So now I can log in to the camera, and so as you can see here in this exploit command, I was using the SMTP exploit, and I had to provide the username and password for this. I have no idea why it's not needed here, but it is needed here, but here we go. And I added this new telnet interface, which will spawn on port 4444 with a passwordless root shell. Now, as you can see, I can log in, and I already have my root prompt. So let's go to the temp directory, and meanwhile, let's convert the generated ELF binary with this convoluted command to this easy to copy paste solution. Now, as you can see, now I have the binary called A, which I just have to add execute privileges, and once I start it, I have my Metapreter session opened. And from here, I have all the tools I need to continue my analysis of this IP camera. For example, from now on, I can upload and download all the files and all the devices, and this is what I used practically to dump the firmware itself. Yes, and here I was looking for the sysinfo command, and as you can see, yes, this is the little-endian MIPS device with a very, very old Linux version. Unfortunately, this is not the only issue with this camera firmware, as there are others. For example, the password is brute forceable through the cloud. Also, the camera IDs are enumerable. There's also an known RCE, which can be exploited through the cloud connection. There is no publicly available proof of concept code for that, but as far as I know, it's not that hard to figure this out. And as I already mentioned, the clear text, the passwords in the clear text configuration file are also stored in clear text. And for example, if you log in to the camera on an open Wi-Fi network through the mobile app, after authenticating in clear text to the device, you will receive the clear text configuration of the camera. So it's not just that you instantly leak your camera password, but for example, your home Wi-Fi password as well. And I also find it pretty bad design that there is no user interface button to turn off the cloud connection. Yeah, and talking about the cloud connection, it's very interesting that the servers for the cloud connection are under Hong Kong and China domain, uh, which is pretty bad because depending on the network of the IP camera and the client, if both devices are behind net, yeah, it means that the whole camera stream and everything will go through these cloud servers. Yeah, not good. So what can you do with devices like this? I have screenshotted the researchers from Cybereason here because I believe that their recommendation is the wisest of all. And we advise everyone who owns this camera to just discard it and throw it in the trash. And yeah, practically this is what you can do with these type of devices. Like security is so bad in these, and there are no patches, you are out of luck. If you really want, you can do some stuff with it. For example, I found that this shell script file at system init ipcam sh, it persits through reboots, so everything you put here will remain and will run at runtime. I had to use some sleeps for unknown reasons, but practically what you can do here is that you change the root password of the device, so it's not the same 123456 anymore. And you can also run iptables command, for example, to turn off the full cloud experience. I was using this command, which blocks all kind of UDP traffic except for DNS resolution. And you can also disable the telnet port through this. So thank you, everyone. That is all what I wanted to share with you today. If you are interested in more exploits, more write-ups about this type of devices, I recommend you to visit these links.